Okay, so the last shape in this section is the parabola. And so this is going to be long, so you might want to do this video in a couple of sittings. Um, or, grab some ice cream or chips or something while you're doing this. That's the bonus of being at home and doing this. So we're going to talk about the parabola. Now, we've done all kinds of things with the parabola over the last couple of years in math. So we know that the parabola is usually an x squared. It's usually a trinomial, like x squared plus 6x plus 9 or something like that. So the only parabolas that we've really dealt with are ones that open up or ones that open down. We're going to add to that, and we're going to say they could open to the side, either left or right. So we're going to talk about some terms, and then I'm going to make some notes for you, and then we'll do some examples. All right, so when we're talking about a parabola, there are some terms that we need to talk about. Oh, it defaulted back. I don't like that. Let's go a little bit thicker. Okay. So when we're talking about the parabola, there are some terms that we want to talk about. So I'm just going to put just a random parabola. I'm just going to put it right here. Okay. No reason. Just want to. All right. So, let's go to maybe blue. When we talk about a parabola, there is always what's called an axis of symmetry. An axis of symmetry is a line that goes through the vertex and it creates a mirror image on either side. So right here, we usually draw the axis of symmetry as a dotted line. That would be the axis of symmetry. Because this line is going up and down, because it's a line, it has an equation that goes with it. Because it's straight up and down, it's all the y values. It's up high, it's down low, and everything in between. So it's all the y values, but it is a specific x value. So if this was at, let's say 1, 2, 3, I'm going to sneeze just a second. Sorry. That probably sounds great on the video. So the axis of symmetry with this would probably be something like x is equal to 3. All right. Somewhere along the axis of symmetry, and always the way I put it is inside the cup. So inside the cup here in this area somewhere, there's going to be what's called a focus point. So maybe the focus point is right here. We're going to talk about what that focus point is in a second. And so there's going to be a specific amount, a specific distance, a specific number of squares, if you start at the vertex to get to where the focus point is. That same distance, but in the opposite direction below, there's going to be a line. This line is called, and this is the only place I've ever seen this word, this is called the directrix. It is the same distance away from the vertex as the focus point is. Now, again, because it's a line, it's going to have an equation attached to it. Now, because the line is going across, that means that it's all the x values, right? It's back here at x is -3, it's over here at x is 7, and everything in between. But it's at a very specific y value. It's at a specific height. And so maybe that specific height, let's say, is -8. It seems like it's pretty far down there. So let's say that is at y is equal to -8. So it has an equation attached to it. So that vertex would be exactly halfway between the focus point and the directrix. Now let me tell you how they explain what these two things are. The focus point and the directrix are placed in such a way so that if I decided to draw a line from this focus point to anywhere on the parabola, let's say I chose that point right there on the parabola, and then from that same point, I were to draw a line down to the directrix. Now again, I can't draw, so this is my fault. This line and this line should be the same length. And it should work that way no matter where I decide to draw my line from. So if I decide to draw my line from my focus point, let's say out here, and then from that point went down to the directrix, this line and this line should be, in theory, the same length. I know they're not on my drawing, but they should be. So we have a focus point right here. So we have a focus point right here. We have a vertex right here. We have a directrix down here, and we have that axis of symmetry going through. All right, so time to make some notes. So if something is opening up or down, if a parabola is opening up or down, all right, I'm going to get rid of some, I just need some space to write. So there. If the parabola is opening up or down, standard form is going to look like this. X minus h squared is equal to 4p times y minus k. The only thing that is squared is the x minus h squared, because remember, in a parabola, it's always an x squared graph. So that's why x minus h is squared. All right, now, some things we need to say. The equation of, so the vertex, let's start there. The vertex is h and k, just like in everything else, your center is h and k. Your vertex, which is in the middle between your focus and your directrix, that is your h and your k. P is the distance between the vertex and the focus point, okay? So the distance from the focus point to the vertex, that is P. So if you went up 5 squares, then your P is 5, all right? So the coordinates for the focus, notice if it's opening up and down, if it's opening up or down, then, sorry, I'm just reading notes here. If it's opening up or down, then from my vertex, I'm going up to get to the focus point. So what's going to change is my y values because I'm going up. So my focus point, the x value is the same. However, the y value is whatever the y value in my vertex was plus p because I'm going up p spaces. All right. The directrix is y. I don't know why I put a bracket there. I didn't need one. The directrix is y is equal to whatever your y value in your vertex is minus p, because the distance from the vertex down to the directrix is the same as between the vertex and the focus. So it's k minus p. Your axis of symmetry is x is equal to whatever the x value is in your vertex and in your focus. So it's x is equal to h. Now, the only other note about this is if P is positive, then the parabola opens up like this one. If your P works out to be negative, then your parabola opens down. It's upside down, okay? Your parabola would open the other way. It would open upside down. All right, so that is if the parabola opens up or down, but it doesn't always open up or down when we're talking about a conic section. Sometimes it opens left to right. It won't be diagonal. I get that question all the time. It won't be diagonal. It will only either be up and down or left and right. So again, just a quick sketch, and I'll make it just small. So if, let's say, here's your vertex and it's opening this way, your axis of symmetry would now be going horizontally instead of vertically. Your focus point has to be inside the cup, so it might be right there. Your directrix would have to be the same distance away, so here. And I think that's it. Okay, so if it's opening left or right, what changes in the standard form is that now it is the y minus k that is changing, that is squared, and it's alone over here. And the x minus h is over on the other side, and it's not squared. So when it opens left to right, the thing that is squared is the y. In terms of your vertex, nothing changes. It's still h, it's still h and k. That doesn't change. P is still the distance from the vertex to the focus point. But now to get from your vertex to your focus point, you have to move horizontally. So that's going to affect your x values. So your focus point is going to be h plus p and k. Your directrix is now going to be, it's all the y values, right? Because it's going up and down. So it's going to be, and again, I tried to make a point and it's not, it's like an equation. It's going to be x is equal to h minus p. Your axis of symmetry is now a horizontal line. So the equation is going to be y is equal to whatever k is, because it's at a very specific height and it's at the same height as your vertex. If your p is positive, then the parabola opens to the right, like this one. If your p is negative, then it opens to the left. So now we need to talk about general form. That's all the notes for the parabola in standard form. So I'm going to give you notes on all the shapes, because on a test, one of the things that I would do is I would actually give you an equation in general form and ask you what shape it is. You really should be able to tell just by looking at it, because general form for any of these shapes is the same. It's ax squared plus by squared plus dx plus ey plus f equals 0. Now, if your a or b is 0, meaning you don't have an x squared or you don't have a y squared. Then you have a parabola. Because remember, think back to standard form. Depending if it opens up or down, then the x minus h part is squared, but the y minus k is not. And if it opens left to right, that's reversed. So you're only going to have an x squared or a y squared. If A or B, no, if A and B are opposite signs, so one's positive, one's negative, then you have a hyperbola. If A and B are the same sign, but different numbers, then you have an ellipse. And if A and B are both 1, then that's a circle. So I should be able to give you something like, I don't know, 3x squared minus 5y squared plus 6x minus 9y plus 17 equals 0. And if I asked you what shape is that, because your x squared is positive but your y squared is negative, they're opposite signs, this is a hyperbola. And I didn't have to do any work, I just had to look at it. And so if I gave you 4y squared minus 6x plus 3y minus 7 equals 0, well, I only have a y squared, I don't have an x squared, so that's a parabola. This should be free points on a test. Honestly, I should give you 4 or 5 of these, say what shape is it. As long as you know those 4 things, then it's really easy to tell, and it doesn't really take any work at all. You just look at it and you know. Okay, there are 4 examples. I've already done example 4 because it's just talking about the different types of conic sections. So I've already done that. Example 3 is just drawing a picture, but we're going to do that right as we do them. So I'm really only going to do examples 1 and 2 on page 166. I'm just going to do examples 1 and 2. You may want to pause me, take a break, wait till tomorrow, whatever. It's up to you. But I'm going to do this all in one video so I get it done and you can pause as you need to. That's the beauty. Can't pause me at school. All right. So example number 1 says, write the equation for each parabola in standard form and in general form. And so in example 1a, the information that they give us is that the focus point, not the vertex, but the focus point is at 2 and 5, and the directrix is x is equal to 6. So they don't give me much information to go on here. I'm a visual person, like I said before, and so personally, I would draw this out simply because it helps me to know what I'm doing a little bit better. Because if the focus point is at 2 and 5, so 1, 2, 1, 2, 3, 4, 5, let's say that's right there. And the directrix is x is equal to 6. So 2, 3, 4, 5, 6. This is the directrix here at 6, and it's x is equal to 6, which means it's all the y values. That means it's a vertical line going this way. If the focus point is at 2 and 5, and the directrix is at 6, that's x is equal to 6, then I have moved horizontally. I have moved to the side. The vertex has to be exactly halfway between the focus point and the directrix. So if the focus point is at 2 and this is at 6, that's a distance of 4 squares. So that means 2 squares this way is going to be my vertex, which would make it at 4 and 5. I also now know what way it has to open. It has to open this way, because remember that focus point needs to be in the cup, inside the parabola, and the directrix should be sort of behind it. So that means that standard form has got to be y minus k squared is equal to 4p times x minus h. Has to be that. Because if it's opening left to right, then the y is the part that's squared. So I already figured out that my vertex, my h and my k, are 4 and 5. So it's going to be y minus 5 squared. And it's going to be x minus 4. Now, what is p? I had to go a distance of 2. There is a space of 2 squares in between the focus point and the vertex. Now, you always start from the vertex. I am going backwards. I'm going to the left 2. So that means my p is negative 2. So it's 4 times negative 2. So I have y minus 5 squared is equal to negative 8 times x minus 4. This is standard form. All you have to do is multiply the 4 and the p together. That is standard form. So they also want it in general form. Well, that's just a matter of expanding it out. This is y squared minus 10y plus 25 is equal to negative 8x plus 32. Move everything over to one side. I have y squared plus 8x minus 10y, and 25 minus 32 is minus 7 is equal to 0. And there I have it in general form, okay? So if you have a hard time getting started, I recommend going over here and just doing a little drawing. I find the drawing really helps me just to think it through and get it started. But I really find a lot of people benefit from giving a quick little drawing. Okay, so example 1b, it says passes through 5 and 2. So that's really just a point on the parabola. Has a vertex of 4 and 3. So that's an h and k. And it opens down. So the fact that it opens down actually gives me a lot of information, because if it opens down, that means it has to be in the form x minus h squared is equal to 4p times y minus k. Has to be in that, because if it opens up or down, the x is the part that's squared. I already have an h and a k because I have a vertex. So it's going to be x minus 4 squared, and it's going to be y minus 3. The question that I have is about that p. What is the p? So this I actually don't need to draw, because the reason why they give me this point is my vertex is an h and a k. A point is an x and a y. And if I know that the equation is x minus h squared is equal to 4p times y minus k, I have an x, I have a y, I have an h, I have a k, I can isolate and get my p, because x is 5 minus h, which is 4, is equal to 4p times y, which is 2, minus k, which is 3. So I have 5 take away 4, that's 1, squared is 1. I have 2 take away 3, which is negative 1, times 4, which is negative 4p. So p is negative 1/4, right? Because I just divided both sides. So, and it makes sense that it's negative because the parabola opens down. So the only thing I have to do to put it in standard form is 4 times negative a fourth is negative 1. You can put the 1 there if you want, but it's unnecessary. And so this is standard form. To put it in general form, I'm just going to expand it out. And so then move everything over to one side. X squared minus 8x plus y, and 16 minus 3 would be plus 13 is equal to 0. So that would be general form. All right, so that's example 1. Example number 2. Example number 2. Yeah, I don't think that they gave me a little tip that said the stroke thing works, but I think I like the area one better. Let's just make it bigger. Okay, so example number 2 is about, of course, going from general form to standard form. However, it's actually kind of easier in this case because you're only going to have to complete the square once because only one thing is squared. So there's only one example in example 2. There's no A and B. So in that one, they give us y squared minus 4x plus 2y plus 5 is equal to 0. And they want us to find the coordinates of the focus, the vertex, equation of the directrix, equation of the axis of symmetry, and what direction does it open. So they just basically want to know all the information about this problem. So first off, whatever is squared, whatever variable is squared, get all of those on the left. So y squared plus 2y, because the y is the part that's squared. Anything else take to the other side. So 4x minus 5. Now, over here where the y's are, I need to complete the square. So I'm going to take 2. I'm going to divide it by 2, which is 1. I'm going to square it, which is 1. So I'm going to add 1 and subtract 1. So this is a perfect square trinomial. It is y plus 1 squared. I'm going to take this minus 1 and I'm going to move it over here. So I have 4x, and it would be negative 5 plus 1, which would be negative 4. I'm almost to standard form already. So y plus 1 squared, the only thing I need to do is whatever number is in front of the x. In this case, it works out nicely because it's a 4. Even if it's not a nice number, take that out as a common factor. So I'm going to take 4 out, which would leave me with x minus 1. All right, so my vertex is going to be 1 and negative 1. That's my vertex. And again, they didn't ask me to draw it, but I'm going to anyway. The vertex is 1 and negative 1. So it's right here. Because the y is the thing that is squared, I know it either opens left or right. I'm not sure which yet, but I know it opens left or right. Whatever is here, in this case, it happens to be a nice 4, but whatever number is there, that is your 4p. So in this case, 4p is 4 because that's what's there. So if I divide both sides by 4, I get that p is 1. Now it's a positive 1. So we know it opens left or right, but because p is positive, that means that this is going to open to the right. So we know it's going to open this way. Now, if p is 1, we are going to go across 1 square. So if it was at 1 and negative 1, the focus is going to be at 2 and negative 1 because I just went forward 1 square. So the focus is 2 and negative 1. The directrix is back 1, which actually brings me to 0. So it's here. So my directrix is x is equal to 0. My axis of symmetry is the line that cuts that parabola directly in half. So it's here. So it's a horizontal line, meaning it's a very specific y value. It's at a very specific height. It is at y is equal to -1. And so I've just given them all the information that they wanted. Where the vertex is, the fact that it opens to the right, what's the focus point, what's the directrix, and what's the axis of symmetry. That's it. So I've posted homework on the parabola. I haven't seen homework from your hyperbole yet either. So those are some things that you need to work on and get caught up. All right. Talk to you again soon. Bye.